Hey students, welcome to IIT JEE Neet classes. This is Ashok, chemistry faculty. Today I am explaining most important named reactions for coming NEET examination. Our main target is to crack NEET exam. In chemistry particularly to get 150 plus marks in coming NEET exam is our main target. So to get 150 plus marks in chemistry, must should be major role is organic chemistry. Organic chemistry play a major role in that, particularly the named reactions play a major role to get good marks in coming NEET examination. So all of you focus on named reactions. In previous video I explained Gru's process, Darjan's method, Finkelstein reaction, Schwartz reaction and Hunts-Decker reaction and Williamson synthesis from haloalkanes and haloarenes chapter. In this video, I am going to explain the remaining named reactions. The next reaction is Sandmeyer's reaction. In this Sandmeyer reaction, first the aromatic primary amine, that is aniline. This is aniline, aromatic primary amine. First reacted with sodium nitrite and HCl at 0 to 5 degrees centigrade. It will be converted into benzene diazonium chloride. The aniline aromatic primary amine converted into benzene diazonium chloride. So benzene diazonium chloride, BDC. So this is the intermediate molecule. Thus that benzene diazonium chloride further it is react with chlorine. This benzene diazonium chloride further react with this benzene diazonium chloride when heated with CuCl HCl or CuBr in presence of HBr produces corresponding aryl halides. In CuCl, chlorine is replaces nitrogen, chlorobenzene will form. In CuBr, bromine replaces the nitrogen atom converted into bromobenzene. So this reaction is called Sandmeyer reaction. Benzene diazonium chloride react with CuCl HCl or CuBr HBr. This CuCl chloride ion replaces nitrogen molecule. In CuBr, bromide ion replaces nitrogen molecule. We can get chlorobenzene and bromobenzene. If you want to get iodobenzene from benzene diazonium chloride, this benzene diazonium chloride is simply treated with potassium iodide without having any copper catalyst. Just it will become iodobenzene. Iodobenzene. So benzene diazonium chloride heated with potassium iodide. That iodide ion replaces N2 molecule. Iodobenzene will form. No need any copper catalyst in this reaction. The next is Gutterman reaction. In Gutterman reaction also benzene diazonium chloride react with copper catalyst. Before we use CuCl, now only copper in presence of HCl, otherwise copper in presence of HBr. So this chloride ion replaces nitrogen molecule. We can get chlorobenzene. Here Br minus ion replaces nitrogen. We can get bromobenzene. This reaction is called Gutterman reaction. The next reaction is Balch-Schiemann reaction. In Balch-Schiemann reaction, this benzene diazonium chloride is treated with BF3 Lewis acid in presence of HF. By heating, this fluoride ion replaces nitrogen molecule. We can get fluorobenzene. So to prepare fluorobenzene, we require Balch-Schiemann reaction. Benzene diazonium chloride reacted with BF3 in presence of HF. By heating, fluoride ion replaces N2 molecule. We can get fluorobenzene. Sometimes we will write here HbF4 also, hydrogen fluoroborate also we can use to replace N2 molecule. So Sandmeyer reaction, Gutterman reaction and Baldus-Kieman reaction, all these reactions are obtained from benzene diazonium chloride. So the chlorobenzene and bromobenzene and fluorobenzene and iodobenzene easy we can prepare from benzene diazonium chloride. So benzene diazonium chloride is the best reagent molecule to convert into haloarenes. The next process is Dow's process. In Dow's process, the chlorobenzene is treated with NaOH at 360 degrees centigrade. We can get sodium benzoxide. Further acidification, that is dilute HCl, it is treated with dilute HCl, we can get finally phenol. So actually this reaction, Dow's process, proceeds by the formation of benzyne intermediate. If you see the Dow's process mechanism, first chlorobenzene is treated with NaOH. In that OH minus take out this proton. So here benzyne intermediate is formed. Further it is treated with OH minus. This will move here, OH will attack. Then further it is treated with NaOH. This hydrogen replaces by ONA. Sodium phenoxide is formed. ONA. This negative charge take out this proton. O minus will become, this O minus take out Na plus from this NaOH, become sodium phenoxide. So further it undergo acidification. Finally we can get phenol. So this is the benzyne intermediate. So Dow's process followed benzyne intermediate. So once more the Dow's process mechanism, if you see, in that OH minus take out proton from benzene, then CH bonding electron will move towards benzene, then Cl minus will be removed, then benzyne intermediate will form, triple bond will form between the carbon atoms. Further this OH minus again attack to the one of the carbon. So this pi bonding electrons will move towards one of the carbon. This carbon getting negative charge, this carbon getting positive charge, then OH minus will attack. So here this negative charge is take out proton from OH. Further we added one more NaOH. Then this O minus take out this Na plus from that NaOH, become sodium phenoxide. This sodium phenoxide further acidification. Finally we can get phenol. So this is the Dow's process. The next most important reaction is Wood's reaction. In Wood's reaction, alkyl halides react with sodium in presence of dry ether. Must and should be 2 moles of alkyl halides react with sodium in presence of dry ether. To give hydrocarbons containing double the number of carbon atoms present in the alkyl halide. In alkyl halide only one carbon is present, but in alkane, that is a hydrocarbon, we can get 2 carbon atoms. In Wood's reaction, majorly we can prepare even number of carbon atoms. Containing hydrocarbons. This reaction is known as Wood's reaction. For example, 2 moles of ethyl chloride when react with sodium in presence of dry ether. So we can get a C2H5. Total how many carbons? 4 carbons. This is butane plus 2NaCl. So in ethyl chloride, how many carbons are there? 2 carbons. But in the obtaining product, 4 carbons. Double the number of carbon atoms of alkyl halide. The product is formed. Mainly in this method, even number of carbon atoms of alkanes are formed. That is most important in Wurtz reaction. The next reaction is Wurtz-Fittig reaction. In Wurtz-Fittig reaction, 1 mole of haloarene reacted with sodium. In Wurtz-Fittig reaction, 1 mole of haloarene and 1 mole of alkyl halide react with sodium in presence of dry ether. In presence of dry ether, we can get alkyl arenes. For example, chlorobenzene and methyl chloride reacted with sodium in presence of dry ether. We can get methyl benzene, that is toluene. So the byproduct is NaCl. In Wurtz-Fittig reaction, the side products, some little amount of alkanes, that is hydrocarbons, and also some little amount of diphenyls or biphenyls also obtained as byproducts. So but main product is alkyl arene. Wurtz-Fittig reaction, the main product is alkyl arene. These two are little amount of small side products are obtained. Then Fittig reaction. In Fittig reaction, completely 2 moles of haloarenes react with sodium in presence of dry ether. We can get biphenyl or diphenyl as the products, or biphenyls. The byproduct is NaCl. Both phenyl groups are joined to each other. So this is the Fittig reaction. In Wurtz reaction, we can get alkyl hydrocarbons. In Wurtz-Fittig reaction, we can get alkyl arenes. Then Fittig reaction, we can get biphenyls or diphenyls. So this is the 3 reactions: Wurtz reaction, Wurtz-Fittig reaction, and Fittig reaction. So these are the named reactions we observed in haloalkanes and haloarenes chapter. Further, I explained alcohols, phenols, ether chapter, complete named reactions. All my dear students and YouTube viewers, please subscribe my YouTube channel and click bell icon for daily JEE and NEET boosts. Thank you, one and all.